And this is chapter number 11, the console input output. So what this console means? Console means keyboard and VDU, visual display unit. Dennis Ritchie, actually he wanted C to remain very compact, very small. So he deliberately omitted the input output from this language. That means C has no provision for receiving data from any of the input devices, like the keyboard and disk, or either the sending of data to output devices. Then the question arises, how do we manage input output? We have already seen we have been using printf and scanf. If C has nothing to offer for input output, then how we are going to input output? So there are types of input output. The input output can be, the input can be from say keyboard, from a file. The output can be to a file, to a visual display unit. And what C has done, because operating system has its own facility for inputting and outputting the data from and to the files and devices. The C has done exactly that. The C compiler uses the quality or the facility of the operating system, input-output facility of OS, to get its work done. There are various standard input-output functions being made, and they are placed in the libraries. And these libraries are available with all the C compilers. And almost all the functions that are required will file in the library of input-output functions. Printf, scanf, all these, depending upon the operating system being used, they are being shown, they are being taken, and they are being formatted the way OS wants to do. There are numerous library functions which are available in input-output, and we can classify them in three broad categories. The first is console input functions. This console input-output functions, this is to receive input from keyboard or write the output or show the output in visual display unit. It can be on your monitor or a small screen. File input-output functions, the function which is to perform input-output operations on some disk or a file. We start with console input-output functions. So the screen and keyboard, they are together known as the console. This is the console, and these functions are further classified into two categories, which is the formatted and unformatted console input-output applications or functions. So what is the difference between the formatted and unformatted? You want to print certain values, and you want to print certain values in certain order so that they must look arranged, formatted. If you don't want, then it is okay. You want something or some numbers to be, or specific number to come after decimal point. This is the formatting. I'll show you how it is done. First of all, let us know console input-output functions. So they are formatted functions and unformatted functions. These formatted functions, the type is the character, the integer, the float and string. In the unformatted functions, we have character, integer, float and string. In the formatted function, in this character, we have scanf and printf for output. Scanf, printf, scanf, printf, scanf, printf. This is for formatted functions. For unformatted functions, for character, we have get ch, che and get char. For output, we have put ch and put char. We don't have anything for int, float. But for strings, we have getAs and putAs. Formatted console input-output functions. So we have formatted as well as non-formatted or unformatted console input-output functions. So what are the formatted ones? We want something to be shown the way we want. The printf is what? It is actually showing, or scanf which is taking up. The printf is showing the things which are being given. Inside it, it has a proper format. That is, these are the list of variables and these are the format string. So this format string is known as format string because this format string is able to format the string and then show. The format string, they may contain the character that are simply printed as they are, or the conversion specification that you will see with %sign, %s, %d like this, %c, and then we have escape sequence that always begins with this slash sign, slash. We call it as a backslash sign. Let us take an example. If you just want to print the average and percentage, this is an integer, this is a float, and this average will, because this is simply printf. You want to print average, you want to print is equal to. Now this %d is not printed. This will actually replace average, which is the integer type, to %d. Then this slash n will also not be printed because slash n means the new line. Means if new line is there after this, the next line will start from here, not from here. Next content will start from here. Similarly, percentage is simple, content or string. It will be printed, is equal to will be printed. But this %f, as soon as we receive or the compiler finds out the %, it will not print %f, but it will transfer the value which is after this to this point. So what you will see here, average, percentage, and these are the values which are being taken. And this is the, if you are dealing with Turbo C and C++ compiler, use 6 after decimal 6 values. This is called the precision. So this is how it is being done. This percentage and this backslash sign, they have a special meaning. They say what to be done, but these are simply dumped. These are simply taken and being dumped on the screen or wherever you want. So we have format specification. This %d, %f, all which you give in printf, these are called format specifiers. And they tell printf to do what? To show something that is integer, that is float, on the screen or on the file. So we have various data type, and what are the format specifier we generally use? This is being given as a C template. So we have integer, we have short integer. For that we use %d, %i. For short unsigned we use %u. Long unsigned we use %ld. Long unsigned we use %lu. Unsigned hexadecimal we use %x, and unsigned octal we use %o. For the real thing we use float and double. This is %f and %lf. For character we use signed character and unsigned character, %c for both. For string we use %f. We can also provide the optional specifier. For example, we have dd, then dot. So this dd means digits, which is specifying the field width. How much is the width? I'll just show you that example of that. But before that, you must understand this dd, and after this we have minus sign. So this is means this dd which is preceded by minus sign. So this minus sign says that you have to left justify the output. While this dot, if you have a dd and a dot, so this decimal point separation field width from the precision. Precision is actually the value which is coming after the dots. How many values do you want? So let us see how to do that. We'll take an example before that. If you just write %d, it will show the way it has to be in a default manner. But if you write %10d, that means it will print the variable as a decimal integer, this %d, in a field of 10 columns. So there will be 10 columns in all. All these number of columns will be 10. And because by default it is justified on the right, this right justification is there. So if you always it will start from here. This number like goes like that. But you essentially want, no, I don't want it to start from here. I want it to start from here. For that you give -10d. This is for specifically making values start from the left, that is the left justification, and whichever area is left in this case or this case, that will be padded with a blank. Let us take an example. 63, you have %d, %2d, %4d, %6d, -6d. All this will be shown like this, and these are the numbers because they, this weight is just 63. So it will be just shown like this from 0 to this, wherever the content goes. But I'll give an example of exactly this, how this minus would work. Let us take this example. You want to show %f, %f, %f. Again, you have to show %f, %f, %f. But the way the output is like this. Now, this is not in very good order. Though the results are there, but %f is also there. You have a value which is followed by 6 digits, which is the precision value. And if no digit is there, you put a 0, or the compiler puts a 0. Now, you want it to be proper. For that, what you are going to use, you have to use 10.10. 10.1 means you want to give 10 values here, and then this dot, and then 1 value. So this 10 value, then dot, and then you have only this you want, 10.1. So when you find out the result, this will be 5.0, no problem with that. And this is a block, proper block, and it has started from, because this is right justified, this is not left justified. So this is right justified. It started with 0. It took three points, 3 values basically, three locations, I must say, 0, point, and 5. So 0, point, and 5, 0, then point, that is decimal, and 5. All these are padded with a blank. Again, this is a 10 block, and this is a 10 block. So this is 10.1, this is 10, then point, then 1. So actually what is happening here is 10.1. So 10 location for this. In all it will be always 10. See, in all it will be 10 locations only. It will be 10 locations. It will not be, say, 10.1 you have said, so it will be 10 plus 1 plus 1, but that is 12 position. No. Otherwise it would have gone to this value. No. Total in all it will be 10. Then this will be point, and this will be only 1 precision value. So if you take this, or say take this, so only 9 will come. And rest 2 has already been occupied. Rest 8 places are given for these, and they will be right justified. So see, now the result is quite perceptive, and it's looking good. So this format specifier can even be used for displaying a string of characters. Let us see that. We have some characters here, and this is some names. Now you want this to be printed as %20s. So you have given a tape or block size and the content is 20. The blocks count are 20. So when you see the result, you see from 0, from here to this point 10, then from this point to this point 20. So this is 20 and these all are right justified. So this %20s, it has reserved 20 columns and in these 20 columns they are right justified. If you do it -20s, this S will come here, start from here, and this will be sandy, and then this will be this block, or you can say reserved areas will be filled with the blank. Similarly is the case with Ajay Kumar. Ajay Kumar, A will start from here till the time R reaches here, and then we have a blank. Escape sequence. Anything in C which start with this is an escape sequence. Escape sequence is generally used for those which are not seen in or on the display, like the blank, like the tab, like the new line character. All these are escape sequences and they are always followed by a backslash. Say slash and I'll give you a total list of that. This slash and slash T, these are all, this new line character, tab character. Let me show you first. If you want to print this content and you have given slash T, and here you have given slash N. So this will be printed with a tab. See, this you have tab up, and here you have given slash N. So you will go to the next line now, and now the tab, all these tab will take place. So you see, here you have given a content which is not looking very good here, but the formatting you have provided, it is looking great here. So this slash N and this slash T, all these are very important in your programming. Let me give you an idea. Slash N is for new line. If you want to apply the backspace, /B, form feed /F, /T for tab, /R for carriage return, /A for alert. And this C, single quotes and double quotes, these are reserved for C. So if you really want to print this single quote or double quote, you have to put a slash before it, like this. Especially this backslash is also reserved. For that you have to give double slash. This is all. If you want to just give a beep, say /A. /R is, it will take the cursor to the beginning of the line. Let us see an example. If you want to put or print this line, you have a single quote here, double quote here, double quote here. But double quote cannot be printed like this. For that you have an escape sequence. So when you put this escape sequence here, and here, you will print the way you want, which is actually you wanted, because otherwise, if you don't put slash, the backslash, there will be an error. So this is how we print. It can be used with %D, %C, all these specifications are there. But there is something which compiler does. If you give some things which are not making very good sense, so the compiler would give values which are not very appreciable. I'll give you an example for that. See, this is character. Now you want to print this character CH, but okay, %C is good and fine. But how about %D? How about %F? This CH cannot be printed as %D, %F. Even this CH can be printed as %D because it is okay. This is it can be taken as an ASCII value. But what about %F? So all these values have been printed with mismatched format specifier. And if you see the result, this is the result. And as I said, you will not appreciate this result because this is the place where a C programmer has to be very careful. Next is the scanf. Scanf does what? It takes the value. This is the format string, and these are the list of addresses of variable. So address means you use ampersand because scanf does what? Whenever you take the value, or from the keyboard say, when you take the value, it has to be placed somewhere in the memory. For that you have to give the address of the memory. That address is ampersand. And these are the format specifier. Please understand, we put a blank or a space between them, and we don't include the escape sequence inside the format string as far as scanf is concerned. Then we have sprintf and scanf. Printf and scanf does what? Printf prints to the VDU, scanf prints to the or take the value from the keyboard. Now you want not to use this. You want them to be put at some buffer, in some buffer. The content should be, whatever you have entered should be put in some buffer, or content which is to be shown, not to be shown, but it has to be kept in some string or some buffer. So what it does, this sprintf does exactly that. This function is like printf only, but the output is not on the screen, but the array of characters. For example, we have integer, character, float. Now we have taken a character string str, and now this will simply show, printf will do the way it does its activity, but this sprintf, it will take this 3 value from I, ch and a, and it will put it in a string which has been defined here. So when you print a string, it will be like that. So this sprintf will store the content in some array which is the str, not on the screen. I hope you got the idea. So this the counterpart of sprintf is scanf. This exactly does that, which scanf does. It will take the value, but it will not take the value. It will actually take the value in a string, and these two functions become very, very important and handy whenever you are taking the value. You want to do the buffering and take the value one by one or some content, and you want to manipulate them in the way you want. For that we have sprintf and scanf. Then we have unformatted console input output functions. So there are several or various standard library functions which are available to us, and you can deal with a single character, you can deal with string of characters. So the unformatted, we have the way we have scanf. So scanf, what happens here, when you scan the values of some content, whenever you hit an enter value, the thing will stop. Means even before you print or you enter all the values, if you happen to print or enter or press an enter button, then the whole value will not be taken. Only that particular value which is before entering the enter key will be taken. Now how to solve this problem? For that, why not to take single characters, without even waiting for enter key to be hit? For that we have get ch and get che. This get ch and get che, in this they are exactly same, but in this get che we have e. This e is for echo. Echo means when you type, get ch will only take the value. It will not print anything. It will just take the value. While this get ch will take the value also, and it will print the value on the screen also. Now get char, it is similar to the get ch and get che, and it will echo the character what you have typed on the screen, but it would require an enter key to be typed following the character that you have typed. So it wants every time you press an enter. So the difference between get char and you also have a fgetchar. Fgetchar function is a macro, while this function is actually a function. Let us see an example. We have ch, you said okay, press any key to enter, then get ch. So get ch is not going to show you anything. It will not echo. So when you press any key and after this you have pressed anything, nothing will be seen. But after these two lines, when you say get che, so whatever you put, like you have put b, it will be shown as a b on the screen. So this get che will echo b to the screen. Similar is with the get char. It will also show you the character, but it would require an enter also after that. So this will echo character, but it must be followed by an enter key. This is the difference between get char, get che and get ch. Then you have fgetchar. This will echo the character just like this, and it has to be followed by a enter. This put ch and put char is another side of the coin. The way you get, the similar way you put also. So this put ch, put char, put char, they are exactly doing those activities which are the counterparts of the other one. So this put ch will print a, this will print a, this will print a, this will print z, like this. Okay. So I hope you got the idea. This is just a counterpart of the getting. Now this is putting. Getters and putters. This getters will receive a string from the keyboard. Why it is needed? Because scanf has some limitation. Let me show you the limitation. When you enter a name, you say scanf, and when you print it, see, if I enter Jaunty Road, it will only print Jaunty. The roads will not be there because you have a blank space here. You have given a space. So this space will be taken as a end. Now this scanf will take only one value for that, or continuous value. But we want to take complete Jaunty Road. For that you have to use the roads. The function which is called the getters. So getters does what? Getters takes the multi-word string. Scanf cannot take the multi-word string. Getters will take the multi-word string, and it will be terminated by the enter key, and this enter key is /n, and this internally does what? /n will be converted to /0, means it will be replaced by /0 which is actually pointing to the end of the string. So this putS is exactly opposite to getS function, and it is showing this output to the string. So let us have an example. You have for the F putS, or sorry, not F putS but putS. So we have a footballer, we have entered the name, we have getS. So we have taken whatever name is given, we will be taking it. Then we putS. So this will be printed, and putS footballer. So the content which is here, which is the multi-word string, will be shown here. And actually this is sending the base address of the array. So when you type the multi-word string, it will be taking it and it will be showing it also. So this putS multi-word, it will be showing. So let us summarize what we have seen. There is no keyword available in C for doing input-output, and all input-output in C is done using standard library function. And there are various functions available for performing the console input-output. The formatted, unformatted, there are two partitions. So the formatted console input-output functions can force the user to receive the input in certain fixed format, and it will display also in the fixed format. So there are various format specifier and escape sequence which are being used for formal input and output, and unformatted console input-output functions. This is faster because the time which is taken, that is the overhead which is taken to format, is always the scenario. So thank you so much. This is all about the very important chapter, which is the console input-output.